Hey there, everyone. It's Brian Gilmore with HiveMQ. Thank you all for joining. I think we're seeing the participant list fill out here pretty quickly. We're going to get started here with the actual discussion with the great Andy Stanford-Clark and Dominik Obermaier, and we should get everything kicked off here in 2 minutes. So thanks again for joining, and we'll be in a minute. Just a word for everybody who's joining too. We will be recording this session, so please feel free if you have not already submitted questions. And thank you to those who did submit in advance. And then you can post questions directly in the Q&A box within the webinar. And also feel free to just throw them in the chat or wherever you might have it, and we'll try to get to them by the end. If not, like I said, we'll post the slides and the recording of the presentation and all of that. And if there are any additional, popular or pressing questions, we may, we'll type up some answers and get those back to you as part of the package. So wow, 130 people. Hi Simon. Oh, that's from Andy. Andy,
Yeah,
Simon.
it's replying to Simple Sci.
Awesome. So let's get started. I think this is awesome, sort of turnout and get started so we can get as much content in as possible, especially seeing we're recording. So I will move on here. So first of all, quick introduction. Again, I really am just the moderator on this one. But Brian Gilmore, I'm the VP of Community Advocacy at HiveMQ. And I am again, super honored and super excited to be joined by Andy Stanford-Clark, innovation leader at IBM Researcher, also co-founder, co-inventor of MQTT, which is a platform we all just know, love, and many people here have likely built a business or their entire business around it. And then also Dominik Obermaier, who is CTO and co-founder of HiveMQ. You will also see me bowing to him quite a bit in this presentation because he's also my boss. So we're happy to have him here too. And what we're going to do is we're going to move on. We're going to allow both of them to introduce themselves, tell you a little bit about themselves, and then we will get going into talking about what we're celebrating really this week, which is the 25th birthday / anniversary / silver jubilee of the invention of the MQTT protocol and transport, which is super excited. Andy even is wearing a t-shirt. I'm
Even
sure.
got the t-shirt to prove it. There we go. Look.
Yep, this is very, very cool. All right, so let's get started. Like I said, quick 25 years of MQTT Q&A, but first let's introduce the great Dr. Andy Stanford-Clark.
Thanks, Brian. Yes, so I work for IBM UK as my day job, a very fulfilling day job. I work in IBM Research as what we call an innovation leader, looking for cool, transformative, innovative projects to work on. Quite a lot of those are to do with Internet of Things, not surprisingly. Also, in my spare time, I lead a team of quantum ambassadors talking about quantum computing and quantum safe encryption, which is extremely exciting and is the thing to come. I'm an IBM master inventor with, I normally say more than 40 patents, but it is in fact 44 patents, most of which are in Internet of Things technologies. And if that wasn't enough, I spend some of my time visiting UEA, Newcastle and Southampton universities as a visiting professor. And I'm also a fellow of the British Computer Society.
Awesome. Well, thank you very much for joining. Now, Dominik, let's introduce you as well.
Yeah, hey everybody. I'll keep it very brief. Dominik Obermaier. I am one of the founders at HiveMQ, and I have been working in the more than last 10 years on MQTT-based technologies, and I was part of the standardization committee for MQTT version 3 and MQTT version 5. I also spend a bit of time on technologies like MQTT SN, which I hope we can also discuss today. And I also wrote books on IoT technologies, foundations, communication protocols, did university lectures on these topics. So I really enjoy being in the bits and bytes, but also in the high scale architectures that we do here at HiveMQ with the biggest companies in the world. And with that, I'm very excited to hear what you all have on your mind and what we can discuss today.
Hey, awesome, thanks. So quick sort of and I think am I frozen or are
No,
you
we're
guys
good.
frozen?
I
You can
think-
hear me? Okay, cool.
Yep.
All right. So quick sort of history of MQTT here. And I think like we said, 25th birthday, Andy. You were there back in 1999. Excellent stuff. And here we are today in 2024 and looking at 2025 and ahead. For anybody who's attended here, I think if you check out our blogs and you can go to our website, it's hivemq.com/MQTT25. Ian Craigs, who's one of the folks who was there also since the beginning, has taken this entire timeline and has written just like a wonderful blog series to sort of walk through all of these different phases. But, I think as we have this opportunity to talk with, Andy, especially who was there at the beginning, and Dominik, who's really been able to extend this topic, through, a great company, we should get started with this sort of first phase, which we are calling pre-standardization from 1999 to 2012. So with that, I'm going to actually stop the slide sharing. We're just going to go to a fireside chat with no fire, and yeah.
And no chat.
Yeah, exactly. And hopefully if I was having some internet issues, but I think we should be good here. So I think, Andy, you and I, shameless plug for our unstructured message podcast, you were on there, and I think one of the things that I really liked hearing from you was sort of like your story of like how you got pulled into the MQTT project. Because I just imagined you sort of sitting there in your mad scientist laboratory, like cooking things up. But I think that to let the audience know exactly how you got roped into this in the beginning, because maybe they'll find an opportunity like that themselves.
Yeah, certainly.
Right.
And it's probably worth saying that MQTT wasn't invented in 1999. That was the birthday. That was the publication of the first version of the spec to the public domain. The conception date was a couple of years before that, with a sort of an agile gestation period in between. So what happened was I was living in America at the time, and IBM in the UK was trying to lure me back to the UK, and they said, "Oh, there's this really cool project. It's to do with SCADA or SCADA if you're in the US." And it involves wiring things up and electronics and wires and stuff. They knew that electronics was my hobby, so I said, "Okay, I'm coming back." So I came back, hot foot from Connecticut, and started what was known as the SCADA project. And essentially, it was so MQ, WebSphere MQ or MQ series back then, which was our enterprise messaging queue-based reliable messaging system, was becoming very popular within the enterprise. But we noticed that a lot of the messages that were being handled by MQ once they got into the enterprise were in fact coming from out in the field. So people would be writing down numbers on a clipboard, they'd be sending them over walkie-talkies, they'll be faxing them, and then zeros would turn into eights and ones would turn into sevens, and eventually someone would key it into a computer, and then MQ would look after it from then on in. Absolutely once and once only guaranteed delivery. And thought, what if we could extend that value proposition of delivering the data into the enterprise from the actual sensor itself? And some of my colleagues said, "Oh yes, we'll just put MQ on these little devices." Yeah, that's not going to fit. And it was very chatty on the network, on these very expensive low bandwidth networks we had back then. 2400 baud dial-up modems and stuff, and satellite links that were costing $1 a minute and stuff like that. And the little devices, think Arduino in today's parlance, Z80 with 16K of memory back then, it simply wasn't going to fit. So we realized we were going to have to build a protocol that was fit for purpose for doing this. Now, back then, there were hundreds of SCADA protocols or SCADA protocols, and they're literally hundreds. Even from the same manufacturer, there were variants of Modbus and Allen Bradley, and you name hundreds of them. And we said, well, what if there was just one more protocol, a kind of one ring to bind them all that you had to implement and support in your enterprise interface, your SCADA headquarters? And that would be free and open and a very concise, succinct, easy to understand spec. And then that would then interface semantically with MQ. So you could then deliver messages from, we talk about IT, OT integration these days, messages from device in the field right through to the enterprise. And that was the basic premise. And from that, MQTT was born. So we proposed a protocol. We did an iterative design. Depending on what, there is a link. In fact, if I get a moment to type, there's a link to the original spec on my website, and it has comments at the bottom. Back before the days of blog posts, this was in 98, 99. People were commenting on whether we should have this feature or that feature, or whether this field should be 8 bits or that. And you can see all the discussion about how we got to that, the release of the first version. And that really was the beginning of what became MQTT. It wasn't called that to start with. It was called the MQ Integrator Pervasive Device Protocol. Yeah. Thanks to IBM marketing people. But we later converged on MQTT, which used to stand for MQ Telemetry Transport. The magic MQ was because it interfaced to IBM's MQ. But once we started the standardization process, which I'm sure we'll come to in a few minutes, we just called it MQTT, rather like BT doesn't stand for British Telecom anymore, it stands for BT. It is just BT. So the association with IBM MQ was lost, and it's just called MQTT now.
Cool. I want to ask one quick follow-up, and then I know, Dominik, you probably have some color or some questions to add as well. So it almost you said that was WebSphere MQ was the sort of the piece that it was. So was MQTT really well, as we would describe it today, the edge version of WebSphere MQ? Was that sort of what started?
Not really. So interestingly, so MQ is queue-based, point-to-point queue messaging. And we'd introduced a thing called the broker, the MQ broker, which was, or MQ series integrator, I think it was called MQSI after a while. And so we'd kind of discovered the notion of pub sub and realized that the one-to-many distribution pattern, rather than having to hardwire this application to this sender to that receiver, and then having to change that if you added another receiver for the same message. The idea of using pub sub, where one person publishes and the broker deals with who else, if anybody, receives that message on the other side, and that's flexible because you just subscribe to the broker. It's a very powerful pattern. So we knew that we wanted MQTT to have that pub sub model built into it, because the idea of not having to go back out into the field and change your device, if you dream up some other one more application to consume the data, seemed very, very natural in a SCADA or IoT world. So that was in from the beginning, even though that wasn't at the time fully compatible with MQ.
Amazing. Dominik, you have any questions or follow-up?
Not so much. I know a bit about the history, but it's always super refreshing to hear about this.
Okay. Well, then let me ask you a question. If you were there with Andy in that room, knowing what you know today, like what would your input have been at that time?
It's a good question. I think if I would have been there back then, I'm pretty sure I couldn't add a lot here, because it's the simplicity, and this is what also drew me a lot into this technology. I was always a huge fan of simplicity, and I still to this day, this is a hill I will die on. Good architecture is simple and it's easy to understand. And I knew the pub sub pattern before I even knew MQTT from messaging. It's like a very traditional message-based pattern. But reusing like all of the layers we've built as technologies, like from Ethernet over to IP and TCP, and then also TLS. Like we've built all of these technologies and stacked them on top. And for some reason, a lot of technologies over the years always try to reinvent the whole wheel. And everybody tries to outsmart everybody who came before them, just to figure out later on, oh, there was a reason why we did it that way. Oh, I didn't know that. And so an MQTT recognizes the fact, okay, we live in a world where TCP/IP is the predominant protocol for all communication. There is technologies like a TLS or SSL probably back then that have been invented. and that everybody's using. And so there's no need to reinvent that. It also has things like, okay, I have encrypted communication channels I can use. I have authentication I can use. And if I'm a bit smart also, I can even use for authorization purposes. So the design decisions that MQTT has is like really like, what's the most minimum thing we can do and not pollute and not spoil it. And my own experience and later on in the standardization committee was also that a big job of standardizing a technology like MQTT is to actually avoid scope creep, like bring in more features that are unnecessary, because there's this one person, this one company who thinks, oh, this would be great. Why don't we do this? Because it would solve my use case completely. But then you make it very complicated for everybody else. And so I think this is the genius of MQTT. And this is why I was attracted to it. And I was like, man, this makes total sense. And there were a few things then also that where I and also the other founders at HiveMQ, where we believed, okay, this is so great. And in addition, we can offer something in addition to it to make it more complete for some of the things that the protocol in itself does not provide and is out of scope. And so it's like, for me, it's also about stacking. It's like playing Legos. And so I think I couldn't really add a lot to it. And so I'm happy to have not been in the room, but I'm happy that I joined, let's say, the whole movement a few years later, there to actually also add value in addition to the protocol.
Awesome.
So
Well,
I should
Andy, who else was in that room?
Yeah, I was going to say, now is probably too late to not to have mentioned Arlen Nipper, who is my co-inventor. So he was the CEO of Arcom Control Systems, which was a SCADA company. They built little boxes that went at the edge to integrate sensors at the edge and send messages back. They were very early with the use of pub/sub in the SCADA world, and it was Arlen and I who together dreamed up the need for and then the actual body of the reality of the meat of MQTT. And just to Dominik's point, the original version, the original specification was called the on-the-wire protocol, OTWP, which was a full soup to nuts from the wire up to application level semantics for pub/sub. And it was during the review process, one of my colleagues in IBM research said, a lot of what you're doing down at the bottom level is kind of reproducing what TCP/IP does. And by the way, TCP/IP does it rather well because they've been doing it since the 1950s. So shouldn't you just like take off all of this crap and stick it on top of TCP/IP and just call it an application level protocol? And we went, aha. Of course. Now, the reason it was originally an on-the-wire protocol was that Arlen and I used to have this, what we used to call our modest plan for world domination. And this was twofold. One was that all devices will one day speak TCP/IP, and two, that they'll all speak MQTT. Now, the first one at that point in 1998-99 was not a given. Most protocols worked over literally a dial-up connection. There was no IP, there was no packet switching. All that stuff was starting to come in, and some people were starting to use it. But point-to-point phone links with a modem which dials out to a specific device, the device answers, and they have a conversation was absolutely the norm. So designing an on-the-wire protocol from the wire up wasn't at all strange until we said, no, TCP is definitely coming. Let's kind of ride that wave and help encourage it.
Nice. So there's actually a pertinent question here from a guest, Alexander Zubin. And he's asking, was there message or was there pub/sub within WebSphere MQ at that point, or did MQTT really invent the pub/sub model in that sort of architecture?
No, it was in MQ. So we'd kind of retrofitted pub/sub into the point-to-point MQ by adding some stuff in the headers and this broker, which was essentially sat on the end point of a whole bunch of MQ queues, saying, "Oh, that's a pub/sub one. I'll do the matching to subscriptions." The subscriptions came in over MQ, so they were with themselves MQ messages, and then I'll send a copy of the message out to any subscribers. So essentially, we had the idea of this broker sitting in the middle, doing publish and subscribe over a point-to-point messaging protocol, a little bit ahead of the conception, the dream of having MQTT out in the field. So it was a combination of it already being in MQ, but also we were working with a small SCADA company or rather Arlen was working with a small SCADA company that was doing pub sub for SCADA systems, and it was making tons and tons of sense to have a broker that all the devices published into, and then applications consuming messages off the back end. So those two things came together. So SCADA, pub sub in the SCADA world plus pub sub in the enterprise world just happened to give perfect planetary alignment at the moment we were designing MQTT. So pub sub was in.
Awesome. Now, just to sort of close out on the pre-standardization era, you had some, I believe, some pretty significant adoption of the platform outside of your sort of expected probably use cases. I know I've heard about Facebook and some others using it for like human to human messaging and stuff like that. What do you think made it immediately applicable outside of the sort of SCADA and IoT realm? And how did you guys view that, and how did you take it at the time?
Well, so I think so we were thinking of standardizing it as a SCADA protocol, and the American Metering Association was very keen to standardize it. But then we found that a company in the US was using it to have a little box which monitored your pacemaker. You put it on the bedside, and it would talk to your pacemaker, gather the data, and send it off over an MQTT link back to the hospital, so that rather than having to go in and be checked, that the pacemaker was calling home to report any abnormalities. And we thought, that's good. And they picked MQTT because it was very frugal on the wire. It was very easy to implement. It was very simple in the sense that it wasn't complicated to implement on a small device, because they didn't have much space. After they'd done the user interface and the data gathering, there wasn't much RAM or ROM left on the chip to put a protocol onto. So they put MQTT on there, and we thought, actually, it's like light bulb moment. This has applicability way beyond SCADA, and which is why we then changed it to that helped us evolve the name from the SCADA protocol to the kind of pervasive device protocol, and then into the telemetry transport, because we were seeing it show up all over the place: agriculture, healthcare, transportation, a lot of use cases in telemetry for vehicles, for smart vehicles, and also trucks with their the payload, the stuff that was in the back of the truck, calling home to report location, or frozen goods getting defrosted, or asset monitoring type applications. So we're seeing it all over the place, and that was really when we realized that this might get really big. But in those days before, probably the first 10 years, I think it's safe to say, I could have told you a list of all the projects in the world that were using MQTT, because I'd actually physically helped on all of them. I was pretty much writing code for all of them. I was flying all over the world, crazy air miles in those days. But that's the beginning of an exponential curve. It's very flat for a long time.
Yeah. And how much did the standardization, so you guys, you put together a committee, you start to formalize this, can you talk a little bit about like what led to that first document of the 3.1.1 specification at the committee level? And Dominik, I think that's about the time that you started to get involved as well, right? So do you want to maybe talk a little bit about how those early versions of MQTT, the standards, it gave you the confidence or whatever you needed to really think about building customer solutions and eventually products around the protocol?
Yeah, so we'd known for a while that we needed it to be a standard, because we're losing bids because we weren't a standard. Quite often there was a binary question quite near the beginning of the RFP which said, "Are you a standard?" And if you said no to that, no point in answering the rest of the questions. So we knew that there were sectors we were missing out on. Because we weren't a standard. We thought of going through IETF to make it an RFC, an internet standard. In fact, I think we did actually write it up as an RFC once, but it never got published. And then we thought, well, being an ISO standard would be a nod to the broad applicability now across many different industries. So now we were way beyond just SCADA. And we were friends with Oasis, which of course is a feeder organization into ISO IEC. And they were very welcoming and very supportive, and they helped us set up a TC. Big shout out to Richard Coppin from IBM, who was the chair of the TC and for many years has skillfully navigated us through the standardization process. But the best thing was, and this was kind of forced upon us in some way, is that they said you can't radically rewrite the spec in order to make the first version of the standard. It has to be very similar to what's gone before, because with standards, code and implementation speaks volumes. So people who are actually using it means that it's obviously got a popular following. It makes it much easier and better as a standard. They didn't want us going off and rewriting a new standard based on MQTT. So we were fine with that because that meant less work. So we changed the name from MQISDP to MQTT. We bumped the version number, and we added, and this is one quite cool thing. The only change we made to the protocol in 10 years was we added username and password authentication to the connect packet, and that was unintentional prescience by me and Arlen, anticipating some of the things in different industries and with a lot of the more scalable infrastructure that was starting to come through then as we headed towards what we now call cloud, that by accident we'd managed to get right the original spec, so we didn't need to change anything. You seem to be on mute, Brian.
Sorry, I had to cough and then I forgot. Dominik, what was your first exposure? Like where in this sort of period did you first see MQTT? How were you exposed to it? And then what made you connect with it in a way that, drove you to build a company around it?
I'll make a very long story very short, but it begins with me flying to the US, sitting on a plane to Kansas City. And I mean, I'm European. So this was the very first time I've been going to the US. And so my first and only exposure back then to US culture was Kansas City.
Welcome to America.
I developed some stereotypes there, which I unfortunately stopped having very soon. No, but just kidding. I was meeting Arlen, one of the co-inventors of MQT, also back then, and he told me about, hey, this is MQTT. This is great. It will change the world. It's awesome. And I was like, okay, I've never heard of it. I mean, it makes sense, but I mean, yeah, it's a technology, right? So, and then on the plane home, I was thinking more about it, because at the same time, there has been a lot of reports. For example, there was Gartner, there was also Forrester, and later on also IDC, who said, oh, there will be billions of connections, billions of devices out there. We will see exponential growth. And until 2025, we will have 50 billion devices. Then IDC later said, no, it's wrong. It's 75 billion devices. And everybody agreed we see an exponential curve, but people disagreed on the timelines. And then I was like, oh man, this is great. But I started my career with an MES system vendor. And so I saw factories from the inside. So I knew that software and stuff should really work. And it's a huge deal if things don't work. And then also back then it was like cloud was still pretty new. I mean, we were working with the cloud already in projects. I mean, just to bring this into perspective, the company was founded 2012. I think EC2 was released from AWS. I think it was 2008 or 2007, something along these lines. This was before Docker was a thing for people who are working in IT. And so then also all the co-founders, we were like, okay, this makes total sense. There is no chance that the web technologies, HTTP in particular, can be used for having millions or even billions of devices. No way. We need something that's lightweight, that actually works. And that also has a way where you can also activate the device and send data to the device without the device constantly basically pulling a server. Which was the way how the web worked. Because if you go now on a web browser and you go to the Wikipedia page, as an example, you type something into the browser, your browser then goes to the server, asks for something, and then it returns. And now just imagine that you have billions of browsers asking once per second a server. You would overload it pretty quick. You don't need billions. A few hundred usually is enough for most servers. And so we were like, okay, we need something else. And then I think we realized the genius of the simplicity of MQTT. But then it was like there was no software out there. There was a open source broker called Mosquito out there that Roger Light made. I think 1 year earlier or so. I think it was pre-version 1 that I was first exposed to it, and it's great. There was the first MQTT clients that have been open sourced. There was a Java implementation as an example. There was a C implementation. And so we're like, okay, this can be huge. It's simple. And then I take the client, and I was a programmer back then. And I was like, okay, it's literally 3 lines of code and it works. How awesome is that? And so I realized compared to all the messaging protocol I was used to, it's completely client-centric. It's that simple to build, to connect the device onto MQTT. And I feel like, okay, this is huge. Okay, but then we ask the question, why doesn't everybody do that? I mean, this should have ruled the world. Why isn't anybody doing that? Why is nobody using that? And then we figured out, okay, there's a few challenges. Like, okay, you have this brokered architecture, which is great, which is the genius about it. But also what's happening if your server is down, if your MQTT server doesn't stop working. And then we were like, oh, simple, make it highly available. And this simple, make it highly available was a defining period for 10 years in my life to get this right. And then we started, okay, but how do you build security into it? Like, how do you bring this into all the proprietary security systems we saw with our automotive customers? And so we found a few things where we said, okay, actually, we can build a commercial product on top of this protocol that scales, that is secure, and can be used by enterprise customers. And so we started out, and the website went online, and people came, and then like literally we had automotive companies calling us and said, hey, guys, we are losing so much money on data transmission. What you have sounds interesting. We've never heard of it. Can you explain it to us? And so we started in the automotive space. This is where HiveMQ started. And from there, we connected everything from escape rooms to drones to now national energy grids in the US. There is components in space, underwater, in mines, like what MQTT is everywhere. And I'm really happy actually to see that our customers are really changing the world. We see here in this company the stuff that whatever will be released in 3 years to market. And I can just tell you that the future is awesome, and the future is built on MQTT. And this is what was exciting for me.
We've got some time allocated here in a minute for that future of MQTT, but Andy, it's got to be very satisfying for you to hear sort of like that, there's a tremendous amount of success that's been built around this. And it's quite a legacy, obviously, that you and Arlen and all the others who are there have put together. I just want to, to sort of close up on the history thing before we get into the future. And then there are a ton of really good technical questions as well that I think folks just want both of your opinions / stamp of approval. It's who better. So talk a little bit about, Andy, the reasoning for creating MQTT 5 when MQTT 3.1.1 was quite successful and people were building companies around it. What made you decide to, do a big leap like that? 4 is, skipped right over and all of that. But I think also what would be really interesting for people to hear is why is there no plan for an MQTT 6, for example? Like,
Sure. Okay. So first of all, the 3 to 5 leap, it wasn't that it was a major revision. It's just that we'd already used 4 as the internal protocol identifier for 3.1.1. So we'd use that one. So we couldn't call it MQTT 4 because we'd now moved the underlying identifier to 5. So we called it MQTT v5. So the main reason for doing it was that we'd moved into the cloud era, and particularly the large distributed cap semantics, the sort of consistency, availability, and whatever P stands for, performance of kind of eventual consistency and messages being distributed across multiple parts of the world. And there were a number of parts of the strict MQTT semantics which didn't sit brilliantly with that, unless you really traded off one of the cap semantics for, often it was performance, for availability or consistency. And so part of it was, could we relax some of the constraints? Like, do you have to have retained messages? Do you have to have QoS2 in order to claim MQTT compliance? And then the other thing was, there were some things which we were putting into topics and payloads which kind of could have been separated out. So things like MIME type fields or metadata fields, which can be describing the payload rather than being in the payload itself. Obviously, you can put everything in the payload, but it makes a lot of sense if you can deal with it separately. And then the other thing was some of the semantics, the underlying semantics of things like session level, so how a session can transcend a number of connections. So if you there's the famous, or the kind of the quintessential truck going through a tunnel and losing connection and then having to reconnect scenario. Do you have to resubscribe to all your topics, or wouldn't it be nice if you could just say, oh, that was just a blip, let's carry on where we were before? And the notion of a session transcending multiple connections does that. Message timeouts, return codes. So now that edge devices were a lot more powerful, we're getting into sort of Arduino class machines and ESP8266s and things with more than just a few K of memory, then it was reasonable to send back a return code to say, this is why I'm not accepting your message or your subscription or what you've just done. Please do something about it, rather than just saying, well, you haven't got enough memory or to implement the code to take that corrective action. So we're just going to close the door on you, which was what we chose to do at the time in 3.3.1.1. But to add return code so that they could be more gracefully handled was a big step up. I think I've covered all the things in MQTT v5, but that's pretty much what was on the table when we said, okay, that's a reasonable melting pot to make into a new version of the standard.
Now, before we talk about why no MQTT 6 yet, perhaps ever, Dominik, like, what did that change from 3.1 to 5 mean for you and for the customers you were working for?
I think it's great. One of the things that you see with standards very often is that you have a standard, and then once the standard gets really successful, you have multiple vendors also innovating on top of the standard. And then at some point of time, like I think, this is my philosophy, the really good standards are not built in an ivory tower. They're built with some real problem in the real world to be solved. And very often they should not be consensus-based. And what's happening with MQTT, I mean, Andy mentioned, there was a lot of users once they started going to different, let's say, areas. As an example, like we did a lot of automotive back then. And then people started, okay, let's not only connect the devices over MQTT because it works. And I mean, we have proven the largest connected car platforms in the world run on HiveMQ. So we have customers that literally have more than 20, 30 million connections on a single installation. So this is something like MQTT really can scale extremely high. But then they were like, okay, we also want to use the simplicity in our backend. Why do I need things like whatever RabbitMQ or AMQP or all these kind of more heavy protocols in the backend when I already have something that works and it's much more cost efficient, and also actually it's more scalable and reliable to what we have there. And so people were using this also. And then you get also into some other things like there was also something introduced called shared subscriptions, which is a way to load balance the traffic on some very, let's say, high frequent topics where a lot of data is going through. And sometimes you have basically data pipes that has much more data than a single, let's say, a microservice or application can consume. And so there is a built-in way in MQTT version 5 to load balance the data streams. So these are all the kind of smaller things that commercial products started to offer. And then there was like, okay, can't we bring it into the spec, because this is obviously useful. While other things, I mean, might be proprietary because actually this is more like niche or use case specific. I think one of the things that was interesting is MQTT was gaining so much traction between the release of version 3.1.1 and version 5 that there were many other vendors that came in, especially on the cloud side, that had existing infrastructure. And there were some people who are really trying to not make MQTT successful before that happened. So we had also cloud vendors. I mean, you can read up on the internet, like the blog posts are still out there, where people argued very heavily against MQTT as a technology and wanted to push their own technologies. But overall, the history showed now, almost 10 years later, that MQTT was the dominant protocol that won over this. And so some of the vendors said, you know what, actually, we should also support that properly. But the thing is, Andy mentioned, it's very, very, very hard to build an MQTT broker that's scalable and works in all cases, it doesn't lose data and so on, in a cloud that you can scale up and down and so on and so on. And so for a very long time, it was very hard to implement the full feature set. So version 5 introduced what's called optional features that are not, you don't need to do that. I think overall it's great because it makes MQTT much more applicable to a lot of things. But this also means the architects also really want to make sure, okay, what do I need? Do I want to have last will and testament, which is one of the greatest features and one of the unique features MQTT provides, which can be optional. So this makes it like, I think the interoperability is something to really look at. And once you decide what kind of feature sets do we want, or I mean, what most people do these days, they just go to an MQTT version 5 100% compliant vendor and just use the full feature set, or they can go somewhere else where only a specific feature set is required. So I think this is where it's great, but it also shows that over time, like there's so much applicability to the protocol that also there's more optionality. So this is where I also do believe it's great that it happened afterwards, and it was very strict in the beginning. But I'm also very glad that MQTT never lost its identity and was also true to its roots on simplicity. And also, I think this is one of the reasons why there's not a lot of appetite for version 6, because, I mean, there's so much you could add if you want, but do you really need that? Do you really, like, does it make it easier? Is there any advantage to it? And so I think MQTT is now more in the place, okay, perhaps this is really good, but what's happening with UDP? Okay, I have a UDP-based use case. I cannot have TCP/IP because I'm on LoRaWAN. I'm on narrowband IoT. I cannot use TCP. So, and for this, there's other technologies that are now being standardized, like MQTT SN, which is also Andy also co-invented this one. So this is MQTT for SN, and this is now a new standardization that's happening. So instead of just convoluting everything and just make it bigger and bigger and more complex for everybody, it was like, okay, this is really good. It works. It's probably good enough. Why for this other one use case that most people don't have, but some people have, why don't we have an additional standardization and solve the problem really, really well? So, and I'm really happy that the committee took that way.
Awesome.
But-
Yeah, and there's a few questions in the queue about some of these new transports like UDP and Quick, and we should cover those during the sort of formal question and answer period. I think just to close up on the future of MQTT, because I think there's one aspect of MQTT that has been there, as far as I know, since the very, very start, that is actually the reason that MQTT will be forever, sort of applicable. And that is the fact that you chose to make the actual message payload undefined, unstructured, anything you want to send. And there was a good question in here. I think it was Alex again, but like, was it designed for like, telemetry data only, or was it for event data or whatever? And I think that if I had to guess what your answer is, it's for anything. I mean, it's like, is it a picture? Is it a JSON document? Is it a sensor reading? Is it whatever? And I think as people start to think about the flexibility and the possibility of building this data pipeline with MQTT, where perhaps you can be moving around machine learning models or, training data or whatever, like, how do you see that particular aspect of the completely unstructured message format as playing into its applicability for everything that's to come in the future? I mean, I think artificial intelligence is at the top of everybody's mind right now, but Andy, you're into quantum computing these days. Like, where does it fit in all these sort of emerging technologies?
Absolutely. So for those of us who are sort of messaging protocol geeks, there's a difference between a protocol and a transport. And the protocol winds up what you're going to send, in other words, how you represent different things like temperatures and voltages and so on, with how you send it. And most of the SCADA protocols were absolutely protocols. It was this is how you send a temperature, a pressure, or whatever. And this is the semantics around how you send it reliably. And it quickly became apparent that far be it for us to tell people how to specify their temperatures or their pressures or their voltages. They might want to do it as a 64-bit floating point rather than an 8-bit int. So we didn't want to get involved in that. So right from the start, we said, no, it has to be payload agnostic, which makes it technically a transport. So it's really be like the postal service. You package up your message, your parcel, your cake you're going to send to your aunt or whatever, throw it into the post box, and somehow it gets delivered to the other end. You don't care how it's delivered, but the point is it's what will you send and what will you do with it when it gets to the other end. And that payload agnostic nature means you can send literally anything over it. Everything from people have abused it by sending voice. We've done an audio simulcast to hundreds of people using MQTT. People send video over it. I don't recommend it because it doesn't do the broker any good. But people often send images, JPEGs from security cameras, right through to 1 bit representations, or actually 1 byte of saying an on or off is just represented by 1 bit, or we'll waste a whole 7 extra bits to send it as a 001 or 000. But the point is that that doesn't limit its applicability, and there are people using it to control industrial processes, quantum computers, cars, reprogramming pacemakers, everything. Everyone's using the reliable delivery, the last will and testament semantics. All those things work together to make a very fit for purpose. And I was going to mention about the V6 there's a sort of necessary and sufficient element to this, is that you can do all these things with V3 and or V5. You don't need to add anything else in order to do all the things we can think of. And as Dom was saying, going to SN for sensor networks means we move away from the TCP network down to the UDP layer, which gets us into a whole class of other things like NB-IoT and LoRa and those kind of protocols. So I think we should kind of thank goodness it's a standard and work with the standard and design our applications to work with those standardized protocols, because they're fit for purpose, and they've kind of stood the test of time for 25 years.
Yeah, it's amazing. Dominik, just to sort of close out on that for you, what is the largest packet you've ever seen? I mean, I guess maybe you can talk about the size of an MQTT packet in terms of the spec, which I'm always wrong and I say it's too low. So I'll let you guys sort of talk about that. But then, I mean, how do you translate that to an actual piece of information or something that could be shipped from, a cargo ship on the ocean to, the back office of some big oil and gas company? What have you seen in terms of those payloads?
So, I mean, the largest payload I've seen for a single MQTT message is 256 megabytes, which is the maximum that it can carry. And the reason why I've seen it is because we test that, of course. But usually this is not what people are trying to do. Most of the time when you're using MQTT, you actually try to make the data you send pretty small, especially when you transmit it over some mobile networks. It's sometimes really interesting. So for people who are not so much in the mobile networks, like here on this phone, I can transmit a lot of data in a month, much more. Like I have, I think, 30 gigabytes per month I can use. This means I can watch YouTube and Netflix all day long, and it's still enough. If I have an industrial application, usually you still pay a lot of money. It got better over time in the last 10 years, but it still takes a lot of time. And the other thing is, the larger the piece of data is that you want to transmit, usually the quote unquote longer it takes. So if you have, let's say, a thin pipe, it takes a very long time. And of course, if I'm here in a city like I'm right now, I have whatever, I can transmit multiple gigabytes in seconds. But this is not true if I have something where I have a very rural deployment. I have whatever oil well or oil rig somewhere. It's here you still can talk about bytes or kilobytes or maximum megabytes. And so you want to have this really small. So I've seen firmware updates being transmitted over MQTT. But I've also seen patterns where you actually notify, for example, a device, let's say a car, you notify, hey, there's a firmware update available for you. Why don't you pick it up at a time convenient for you? For example, when you're charging or when you have Wi-Fi connectivity, so you don't consume all the bandwidth, these kind of things. So I really think like this is a mistake sometimes I also see is that, oh, I have HTTP or I have MQTT, and so I just use everything for everything. I still think good architects have a toolbox and they know exceptionally well which tool to use. And every craftsman has some favorite tools they want to use more often. But at the end of the day, I think it's about having nuance. MQTT is for a lot of use cases really well, but it's not really well if you want to have gigabytes of data and transmit them. You can chunk them. You can do all of this. There's patterns available. But let's be very frank. Let's purpose build things in the architectures that fits the customer needs. And for big data, if you have 200 megabytes of data, why don't you use MQTT to notify and then stream it either over HTTP or even FTP sometimes?
Love it.
That's the thing. I mean, there are enterprise-grade messaging systems, and one of the reasons we've resisted piling more features into MQTT is that there are perfectly good messaging protocols, enterprise-grade, that can do all these kind of things. Two-phase commit semantics and massive messages and all kinds of stuff. We did learn quite early on that chunking messages, chunking big messages into smaller messages is actually much more efficient. Because the problem is if you send a 256 megabyte message, which by the way back in 1999 was what we imagined to be a firmware upgrade, the biggest we can imagine for a firmware upgrade, 256 megs. That's why we set that as a maximum. You really don't want to send 256 megs because if there's a retry, you've got to send the whole 256 megs again. Whereas if you chunk it up and use some sort of intelligent reassembly protocol, then you say, oh, I missed chunks 3 and 7. Then I'll just send those chunks again. So turns out that's actually the better way of doing it. So most MQTT packets are pretty small, numbers of K.
But it's not limited. That's the thing is that like you left the flexibility in. You could have said that this is a 128K message and that's it. And then people would be hitting that ceiling all the time.
Yep.
The point is that the ceiling doesn't exist there really in terms of either message size, practical message size, or practical message format. And for me, that's what comes in the future? It does feel, to Xavier's point, it's like an eternal sort of future-proof thing that we'll always find new use cases. All right, so we got very limited time left. I want to go ahead and I want to just get some of these questions out to you guys. And I think like most of these will be very like 2 thumbs up, absolutely. And then folks can go back to their bosses and say, hey, that's literally one of the guys who co-invented it and one of the guy who's built the biggest company around the protocol said, we're good to go. The first one, softball, I'm going to say I already know the answer to this, and I'm going to say it's yes. But somebody who logged in as anonymous asked about MQTT and it's being applicable for real-time bidirectional communication. I think the answer to this is pretty obvious, but like for card reader PED devices and opening and closing or turning locks on and off, what do you guys think?
Absolutely. I used to have a little clicker that turned on a light in my house, and the message went over Wi-Fi to a broker in the US, back again, and turned on an X10 device, and it was literally click, light comes on. It was a fraction of a second. So it depends what you mean by real time. Energy industry has a different definition of real time. If you're controlling the tip of a lathe, real time is different from what I would call real time. But anything that's sort of a small chunk of a second, yeah, absolutely, and certainly bidirectional. That's one thing people tend to forget is that we tend to say devices publish messages, but they also subscribe to messages for set points and control messages and controlling actuators, fully bidirectional. So yeah, yes.
Yeah.
Awesome. And Dominik, you agree?
Just to add one thing also that it's to add to this. One of our customers, they have 3 to 4 times the amount of traffic on a single installation that WhatsApp does with all of the global infrastructure. So this is like pretty significant size. And they have a SLA that all of the data points produced somewhere in a very, very big country in the world needs to be somewhere centrally in less than 4 seconds. And for 3 to 4 times of all the WhatsApp traffic globally, these guys manage to get it in less than 4 seconds. So yes, you can do this, what also Andy said, but also at a scale that's more than mind-boggling.
Okay. All right, we're gonna rapid fire here. David is asking, what's the best practice to monitor remote device connections to the broker? Is there something built into the spec, or is there something implemented in the, in HiveMQs?
That is exactly what last will and testament is for. So if you publish a retained birth certificate and then you set the last will and testament to be a retained I've now gone offline, then you'll always have a topic that shows the correct status, online status of that device.
Awesome.
So I was explaining to Arlen this mechanism I'd come up with for detecting if something gone offline, and he said, "Oh, so it's kind of like a last will and testament when you die." I say, "Yeah, that's it. And that's why I call that."
Nice. Here's a question from Alexander Salas. He's asking about text-based topic names, and that they can be quite verbose. What are your recommendations in terms of either encoding them, like using shorteners, like UUIDs? What's the sort of best way to do that? And is there something like, is there a way for protobuf to maybe apply some value there?
Yeah.
The last part, I think we would need 15 minutes.
Let's not go there with protocols. But in terms, so we always say that you should have a suitably rich topic name. You shouldn't be compressing things down to ABC, because that will lead to confusion for the application writers. And because MQTT, because by abstracting you away from all the networking gorp and saying this is all about what will you send and what will you do when it gets there, you've now moved up the value stack. So application writers want a semantically rich topic space so that they can understand it unambiguously, but also subscribe in a sort of rich, you're using wildcards and so on sort of way. You can do topic name compression. Has V5 got topic name compression? Did it make
yes. I think people who want to check it out, it's called topic aliasing.
Yeah.
So sorry for interrupting, but just for people who are interested in this, use, as Andy mentioned, a really rich topic name that covers the semantics on what you want to do, and then enable the feature. And then what's happening is, instead of this huge, let's say, name, the client and broker will then only whatever transmit whatever a number 1 or number 2, because both know what 1 would translate to, let's say, this long topic.
Yeah, so it's kind of tokenization. So that was something we actually took from MQTT-SN, and we retrofit or brought into MQTT v5 because it was quite useful, and we wanted to dissuade people from shortening topic names.
Awesome. So yeah, I mean, I think this was fantastic, and as not surprising, we've run out of time. We still have a bunch of really great questions in the queue. I think especially the UDP and quick conversation is something people are hungry for. So maybe we can schedule a follow-up. Maybe Dominik, we can work on a blog with Andy or something to sort of, just outline the answers to a lot of these questions that we weren't able to cover. But again, to everybody who attended, thank you so much. Appreciate it. Thank you very much to Andy and Dominik for, putting yourselves out there and answering and sort of telling your story. And for everybody who joined, we'll be sending out a few pieces of follow-up. Number one, of course, access to the recording, some of the deck and the documents and stuff like that. And we'll figure out a way to put together a bunch of answers to these questions that you guys asked, because it was a fantastic session. And thank you all for sticking around for the entire thing. And we
one more
will
thing. Next Tuesday, raise a glass to
oh yeah, that's right,
on its birthday. So
cake, candles, and champagne for MQTT on the 22nd. Amazing 25 years, Andy. That, like, I mean, here it is. I feel like it's almost just getting started too. So.
Absolutely. And here's to the next 25 years, right?
Absolutely. To the next 25. So thanks so much, guys. And thanks everybody for joining. And we will see you all soon.
Bye, everybody.
Hi. Excellent.